So Kaizen means continuous improvement. And continuous improvement means that you've got your production process set up so that you can monitor it on a continuous basis and you can continuously tweak it to get better and better and better in real time. So I think what happens with the web, one of the great beauties of the web, is you can do this kind of continuous improvement on your product. So you want to be continuously monitoring the product's performance. So in Google's case, if you look at web search, you'll be measuring the relevance of the search results in various ways. You want to be running controlled experiments to see if you can improve on the existing product. And then you want to implement those experiments in real time so the product is continuously getting better. And I'll give you a nice example. It was just in the New York Times last month about voice search. So when Google started doing voice search, which was around 2006, we had no data, zero data. And we offered a service called Goog 411, which is an information service where you can dial Goog 411, and you can then name a business, and the system will offer you some choices. Do you mean? Do you mean? You press a button, hits the right choice, and you can then build that system in a way that allows it to be continuously improved. Now this is important. It uses a cloud computing model in a very fundamental way. Because if you had a voice recognition application that was distributed among a whole bunch of different devices, whether the computers or cell phones or whatever, one device can't learn from another. But if you have something where the voice recognition is set up to the cloud, then the cloud is learning what the right response is, or learning to accurately recognize the voice input on a continuous basis. So you can build not a batch processing model where every now and then you re-estimate a model, which is saying, am I getting this voice recognition right? But you can actually build a system that learns on an hour-by-hour, day-by-day, week-by-week basis. And within a year, Google had a voice recognition system that was better than the best available commercial products. So building a system where you've got a presentation, a response, a way to determine whether what you presented was accurate or not accurate, relevant, correct, etc., then you can build a system which is continuously learning. And I personally think, I'm not going to talk about this now, but I think that's where the economy is headed. Because if you look at what's happening with the Fed or Treasury, more and more we're getting real-time signals about the functioning of the economy, and more often you can do real-time adjustment. So another topic that's important in this area is the role of product management and division of labor. One of the things we strive for at Google is to have one project manager for 11 engineers. It's a kind of Leontief production function. And the project manager is somebody who's managing the product, not necessarily from the engineering level, but all the other issues that come up about user interface and legal approval and matching the features to what the market wants, et cetera, et cetera. And there's a lot of debate within the industry about what the right ratio is, because it's very easy to end up with more managers than you really want or need. In fact, when Carol Bartz became CEO of Yahoo, in her first conference call, she said, yeah, it's terrible. We have one project manager for every 3 engineers. They all argue about what should be done, and not a freaking thing gets done. That was not an exact quote. But I cleaned it up a little bit. And it is an issue because there's this kind of creeping management problem that what you really want to do is get the workers working and have minimal layer of management to make them work on the right things. Okay, so finally the last thing I wanted to, one more topic about that. One of the problems with our education, and I think this is true at both Stanford and Berkeley, is we don't necessarily train people to be project managers. You'd think this would happen in business schools, but it turns out it really doesn't. And part of the problem is there's very little research that goes on in this area. And it's quite an important area. I think there's an emerging field of what you might call nanoeconomics. So there's sort of a level below microeconomics, where you're looking at how do you set up the right incentives, how do you set up the right production models for work at the task level as opposed to at the organizational level. So this is something, what we require is you have to have an undergraduate degree in computer science in order to be a project manager for computer engineers, but that doesn't give you all the skills that are really necessary to do this in an appropriate way. Okay, so the last topic I want to talk about, and this is really kind of the topic that's most central to the theme of the talk, which is economics and innovation, and that's the importance of complementarities. So what happens is everything is part of a system. If you're using Google, you're using an ISP, you're trying to find content, you're using a device. So what the user cares about is how well the entire system functions. So they care about the performance of the device, the internet, the quality of the content, etc. So Google, providing its piece of that system, can't really succeed unless you have high quality offerings in these other dimensions. So for every business that's working in technology, you have to think at the entire system level, and you have to understand how your component or your piece of that system functions in conjunction with those other pieces. So now from a business point of view, of course, everybody wants to be the scarce factor that's complementary to lots of ubiquitous and cheap factors, right? Because if you make left shoes, you'd like right shoes to be very cheap and widely available. So the challenge then is how can any individual player in the industry kind of push the system forward? One interpretation of Moore's law in Silicon Valley is it is a coordination device. So we talk about the power, let's say loosely, the power of a chip increasing, doubling every 18 months. Well, it could double every 12 months, it could double every 24 months. But what's important is everybody agrees that the system is going to be twice as powerful in 18 months. So all those other pieces that go into the system, the memory and the network and all those other components, kind of have a roadmap of how they have to double as well. Because if only one component gets better, the whole system may not really improve. So you do need this kind of coordination device. And of course, since everybody wants to be a scarce factor that's complementary to something that's cheap and available, you're immediately led to think about the role of open source software in these network industries. As you know, Google runs on Linux and Yahoo runs on BSD. If you think about it, it pretty much has to be that way because no company that relies on scalable infrastructure for the internet could actually work with a proprietary operating system, right? Because there's a huge holdup problem. Huge holdup problem that if you ceded control of your primary way to access your product to some third party, that third party has huge control over your functioning, and so the open source is absolutely critical, in my opinion, to having these internet services businesses work. It also means that every company that aspires to be a large company, and who doesn't, a big challenge is how do you commit to openness. You know, when we wrote information rules, well, long as 12 years ago now, we talked about lock-in, which was a common term in the economics literature, but not so widely used externally. Well, now everybody knows about lock-in, and everybody is worried about lock-in because they don't want to cede control of their own environment or a critical component of their own system, ecosystem, to a party that can then have kind of veto power over what they're doing. So you have this challenge of how do you reassure players in your industry that you're not going to exercise that power in the future. So at Google we have things like the Data Liberation Initiative, where you can go to Data Liberation, just do a Google search on it, and you can see how to download all of your data that's available at Google. And we have the Ad Preferences Manager, where you can go to Google and decide what interests you have, or look at the interests that Google thinks you have and correct those interests, or delete them entirely, or opt out entirely from behavioral targeting simply by going to a single unified source. So it's actions like this that are attempting to be commitments to provide that openness which makes people more comfortable with using your system. And that's where I'm ending. Thank you.